Hey guys, I'm Jay. Today is my LeetCode review vlog on the 45th problem, Jump Game 2nd edition. We are given a zero-indexed array of integers, nums of length n. We are initially positioned at nums of 0. Each element nums of I represents the maximum length of a forward jump from index I. In other words, if we are at nums of I, we can jump to any nums of I plus j. Finally, we have to return the minimum number of jumps to reach nums of n-1. The test cases are generated such that you can reach nums of n-1. Let's see the example here. First, we got fifth element in array, and the explanation is the minimum number of jumps to reach to the last index is 2. First, we jump one state from the index 0 to 1, then 3 steps to the last index. And let's analyze the main idea to solve the problem. So for the intuition is we could solve the problem with a greedy algorithm called BFS. Greedy algorithm, BFS, which is graph first search algorithm. The graph first search algorithm, it is very useful to find the minimum path in a graph. So our solution to solve the problem is kind of like the BFS. We have to find the minimum number of jumps to reach to the end index. And let's start with a code here. First, we could have a jumps variable and start it at 0. And the jumps is the number of jumps to get to the last index. Then we could have a variable called current jump end, which stands for the index we are at the current jump. Third, we could have the third variable called farthest, which means the farthest element we can get so far, and we started with 0. Then we can use a for loop to iterate through the nums array and to find the best and the farthest index we can go so far. Then we can have a for loop and the iteration pointer start at 0. And the condition is I is less than nums dot length minus 1. Then we have to increment I. The reason that the condition is I less than nums dot length minus 1 is because we only have to iterate through the array nums from the 0 index to the last second index, as we don't need to jump from the last index, so we can skip the last index. And inside iteration, the first step is we have to update the farthest variable with the maximum of its current value and I plus nums of I. This represents the farthest index reachable from the current position of I. And let's start with the code here first. Farthest is equal to math.max and is current value and I plus nums of I. So the code is we have to update with the maximum of its current value and I plus nums of I. we have to choose the bigger step we can move so far. This code is very similar to the q.push node step of BFS. But here, we are only greatly storing the max reachable index on the next jump. We have to storing the max reachable index on the next jump. Next jump. This is the first step. And the second step is we have to check if I reaches the current jump end. If true, it means we've reached to the end of the current jump. So we have to make this jump an increment jumps variable. We have to check if I is equal to current jump end. If it is true, we have to increment jumps variable and update the current jump end variable with the value of farthest. So this is all of code inside the iteration. And after the iteration, finally, we can return the jumps variable, which represents for the minimum jumps needed to reach to the final index. And let's submit the code to check for the answer. Oops, I spelled it wrong. Let's fix the problem. Yes, it is got accepted. Then let's analyze the time complexity and the space complexity. So for the time complexity, it is big O of n, and n stands for the length of nums array. As we only traverse the array for only one time. And for the space complexity is big O of 1, as we only use three variables to solve the problem, regardless of the length of the nums array. And thank you guys for watching. This is the end for the code review vlog for the problem. You can also check for the detailed notes for this problem, and I got detailed explanation for the BFS algorithm, which is very similar to our solution here. And thank you guys for watching. See you next time.